look up on a clear night, and you can see a few thousand stars. But within the boundaries of the Milky Way alone, there are over 100 billion of them. For every single grain of sand on Earth, there are roughly 10 distinct planets out there in the dark. Statistically, the chemical conditions required for biological life exist in millions of different star systems. Given this density, the galaxy should be saturated with detectable technosignatures, radio wave transmissions, orbital macrostructures, and thermal exhaust of advanced civilizations. Yet, when we point our most sensitive radio telescopes into the abyss, the number of confirmed extraterrestrial signals we capture is exactly 0. This is the Fermi Paradox. It is an aggressive mathematical contradiction. We are observing a massive, inexplicable gap between our probabilistic expectations and our observational data. To resolve this missing data, we have to look past the telescopes and apply two distinct structural frameworks, one based on evolutionary developmental bottlenecks and another based on game-theoretic strategy. In 1950, physicist Enrico Fermi realized that accounting for the volume of stars was only half the problem. The real contradiction lay in the immense span of deep time. The universe is 13.8 billion years old. Earth formed relatively recently. If biological evolution can occur here, it could have occurred on billions of other worlds, billions of years before our solar system even existed. A species that started early would have a massive temporal head start. Through exponential replication, a single civilization could establish outposts that build further outposts, rapidly cascading across neighboring star systems. Even operating under the strict limits of physics, using primitive sublight propulsion methods, a single species mathematically has enough time to cross the entire Milky Way in a mere fraction of cosmic history. A galaxy-spanning civilization would leave massive physical footprints in the data. We should detect Dyson spheres, dimming the light of entire stars, interstellar transit networks, and massive energy consumption signatures. We find none of these. Our comprehensive sky surveys show absolute silence and no evidence of macro-engineering anywhere. Since there is ample time and space for total galactic saturation, this silence suggests a universal mechanism is actively preventing biological matter from reaching technological maturity. This brings us to our first structural framework, the Great Filter. This theory posits that there is an evolutionary barrier, a highly improbable phase transition that halts the formation of spacefaring civilizations. We can map the development of life as a probability matrix. A species must pass sequential checkpoints: the formation of a habitable planet, the spontaneous generation of single-celled life, the leap to complex multicellularity, and the acquisition of tool-using intelligence. The Great Filter assumes that at least one of these nodes acts as a systemic bottleneck. It is a step so exceedingly difficult that the evolutionary failure rate abruptly nears 100%. If this bottleneck is in our evolutionary past, it means abiogenesis or complex intelligence is a severe statistical anomaly. Humanity is an extreme outlier, and the stars are empty because no one else made it this far. But if the bottleneck is not in our past, it waits in our future. This implies that technological maturity leads directly to a near-certain systemic collapse. As a species' technological capacity grows exponentially, its ability to inflict destruction mathematically outpaces its biological and societal control mechanisms. The curiosity driving a civilization to explore space is the exact same trait that builds engineered pathogens, runaway climate feedback loops, or unaligned autonomous intelligences. Under this framework, high-level intelligence is not an apex survival trait. It is a self-limiting biological mechanism that guarantees its own destruction. There is an alternative model. The universe might not be an empty graveyard. It might be populated by rational actors optimizing strictly for survival. This is the dark forest theory, which frames cosmic sociology as a non-cooperative game. Space is vast, meaning civilizations operate under conditions of imperfect information. You can never accurately measure the true intentions or the technological capabilities of another species. Furthermore, the laws of physics impose strict light-speed delays on communication. This constraint makes real-time verification, negotiation, or diplomacy on a cosmic scale physically impossible. When detection immediately implies a potential existential threat and negotiation is structurally impossible, the most rational mathematical strategy is preemptive elimination. Therefore, any species that survives long enough to achieve technological maturity logically deduces the rules of the game. They learn that absolute silence is the only optimal survival strategy. Contrast this game-theoretical equilibrium with humanity's current operational baseline. We actively broadcast unencrypted radio signals and radar emissions directly into deep space. We are functioning as a naive, anomalous node, loudly broadcasting our coordinates into an established matrix of hidden apex predators. The cosmic flatline we observe leaves us with two conclusions. It is either the byproduct of a universal developmental bottleneck or a strategic equilibrium of terror. Regardless of which mathematical model is correct, humanity's current operational position is one of extreme existential fragility. The Fermi Paradox forces a confrontation with the role of the observer in the physical universe. Consciousness is the only known mechanism by which the universe can perceive, measure, or understand itself. If humanity succumbs to the Great Filter or exposes its coordinates in the dark forest, the cosmos loses its only mechanism for subjective experience. Without conscious observers, the stars will continue to burn, but the universe reverts to a purely objective, unobserved thermodynamic state. Whether the universe is structurally lethal or strategically silent, the immense burden of maintaining conscious observation rests entirely on our ability to navigate the math.